Hello and welcome. If you're watching this video, that means you are probably a part of our September 2024 ICD program for the USW 135. This video is going to cover the CAD CAM portion of the class where we made the cutting board using the CNC router. Again, there may be an option in the future where we run a class devoted to the CAD CAM. This class is devoted to how to run the machine and set it up. So I'm going to be covering the CAD CAM here for you in a video, and you guys will be able to come back and look at it as many times as you'd like. So we're going to get started by opening our Vetric VCarve software here. So we're going to find our software, Vetric VCarve. And when you first open a new project, this is what you're going to see right here. And if you have files that you've already been doing before, they're going to be over here under the recently opened folder. If you are working on new files that you're going to start from scratch, you're going to probably go up here to create new file, unless you have a template saved, because this is very similar to a previous job that you've been doing, in which case you may pull it from a template. So you're going to create a new file. This is where the majority of the work is going to get done for setting up everything that you want to do properly. And the job setup here is where we're going to pick whether this is getting milled on one side or two sides. For the cutting board that we're doing, it's only going to be milled on one side, so we're going to have single-sided. We're going to pick the job size of the actual work piece that we have. So this isn't necessarily the size that the cutting board is going to end up. This is the size of material that we're going to start with. So our material should be 16 by 13 and a half by 1 3/8, 1 1/4, something like that. The next box down here is the Z0 position. Again, in the class we're going to cover touching off our tools and setting the Z0 on our workpiece. This is going to display where that is getting set from. Are we setting it from the top of the workpiece, or are we setting it from basically the bottom of the workpiece or the machine bed? We're going to do it from the top of the workpiece because that's the easiest one to touch off on and makes sort of the most logical sense as you're running the machine. It's a good place to start. The XY datum position, same thing. When we get to the machine, we're going to have to talk about which way, where we are orientating and where we are setting the XY 0 when we go to run the machine. In this case, we've got the back left corner as the XY position, so that's where we'll end up putting our tool when we go to cut, is over top of the back left corner of our piece of wood on the machine. The modeling resolution is sort of up to your own. Depends on if you want to look better or keep it simple. I like to keep it simple and make sure my computer runs well. Material settings, you can change the material here. It doesn't really matter what you pick. We are using cherry for the cutting board, so I'm just going to leave it there. And again, it's not really doing much for you. It might auto-populate a couple of your different speeds and feeds, but for the most part, it's not really making any difference. We're going to hit OK, and then we'll get this window here where now we can start to draw stuff. But if we go to the 3D view, we'll actually see like a piece of wood, the top surface of a piece of wood. So 2D is the easiest place to draw and add everything. We'll add in the juice groove lines. We'll add in the actual profile of the cutting board, and we will also add in our image or our logo into the center of this cutting board. So we're going to go up and we're going to start out by drawing a rectangle. And if we anchor point this rectangle right in the center, then we can draw this rectangle pretty easily by just telling it where the center is going to be. So if we're 16 inches long in X, the center is going to be 8. If we're 13.5 inches long in Y, it's going to be negative 6.75 to the center. And then that's going to allow us to set the width and height. And also, if we want, we can spare ourselves the effort of radiusing the corners after the fact if we tell it that we want it externally radiused here in the software. So let's just say we're going to put a 0.75 radius on them, a nice small one. Our width, I'm gonna come in about a 1/2 inch on each side. So if it's 16 inches long, we're gonna come in a 1/2 inch on each side and make it 15. Again, if it's 13.5 tall, we're gonna come in a 1/2 inch on each side and make it 12.5. When I hit create, I should end up with a rectangle with 4 rounded edges that sits centered on this white piece of paper, for lack of a better term. All right, there we go. We can see our radiuses in each of the corners, and again, we're centered up in that box. The white box represents our piece of material that we have to work with, and then again, all the lines are going to be our geometry of our part. Once I create it, I'm going to close it. So that's going to be the outside profile for our piece. In order to make the juice groove consistent, and I think the easiest way is to use a command called offset, which will take the outside profile and offset it either inward or outward, depending on which way you put it, in a particular amount, exactly the same all the way around. So offset's over here on the left under the offset layout tools. I'm going to go inward with it, and hopefully it goes the right way, but what I'm going to do is I'm going to click on the path I want to do first, give it the distance I want it to go in. Let's say 0.75 I think is going to be a much better spot for the juice groove, being how thick it is. And we're going to hit offset, and there we go. It offset it in. Now, when it offset it in, it created sharp corners because we had that checked. You could uncheck that and get it to do the radiuses, or you can custom do your own radius by going over here on the left to the fillet command and using the fillet command to actually radius the corners yourself. Let's say 0.25 because we're coming in a little bit. And I can just come right over the corner and I can click on it and see the radius. Now if it's not enough of a radius, I think that looks a little too small, I can just Control Z to undo, and I can change the size of the radius up here and redo that again. So I can play around with it as many times as I want until I get a radius that I think looks pretty good. Let's say the 0.5 wasn't good. I could back it up and I could match the outside radius with 0.75 and see if I like how that looks. I think I like the 0.5 more. Looks a little bit more consistent. So we go in 0.5 and just left click on each of those corners when you see the little check mark next to the symbol. And voila, we've got our juice groove path and the outside profile of our piece in there. So at least for this project, this is relatively simple. Now just keep in mind that where that juice groove line is, that's the middle of the juice groove going around the cutting board, not one of the edges or the other. So if you think that when you get the juice groove in there, it's a little too close to the edges, you may want to offset this in even further, and then keep in mind that again, maybe halfway between these two is where the actual edge of the juice groove is going to lie. All right, so with that in, those are the two easiest parts. Now what we're going to do is we're going to have to get the logo in here. For this one, as of course, anytime you're doing anything in Buffalo, the first logo we'll put the Bills logo in there. And what I'm going to do is type in Bills logo, which is what I want, and then either black and white silhouette or silhouette. Any of those searches should hopefully get us a nice crisp black and white image, and that black and white image is really what we want if we want to be able to have a very easy time of doing a logo or a design. If you start getting into these colored logos here, it's going to be a little bit more difficult for the program to pick up the different colored edges, and you might get a lot more lines than you were hoping for. Again, these black and white silhouettes are super easy. It converts them really nicely. Likewise, if you have any of these double lined logos like this one right here, this might be a little tricky to get the tool path and everything cutting out on the VCarve software the way you want. So I'm going to recommend going with trying to find single line black and white images is definitely going to be the best. So I'm going to save that right to my downloads. We'll just call it the Bills logo. And when we're back in the VCarve software, okay, we're able to import that. It's going to be called a bitmap. So right here under the file operations, there's an import bitmap or vectors, and that is how you're going to bring in pictures that you can then trace in the software and end up with what we call polylines, or actual lines that are part of your model or your drafted picture. So all of these functions under here under vectors, those are like polylines or vectors where the machine will recognize them and you can make code from them. When you first bring in a picture, until you convert it over to a vector or a polyline, it's just going to be a picture and it's not going to be recognizable by the machine. So the first thing we're going to do is bring that picture in. Just navigate to my downloads and find the logo I just had. All right. This is probably going to be the easiest time to scale the logo and center it up and everything before you convert it into lines. It's just going to be the most consistent one. So it's a little small. I can certainly make that a lot bigger. If I go over to the transform options, there's ones to move. There's also ones to change the size or scale it. And then there are some to align it, which will be what we'll use later to recenter it if we throw it off of center at all. So this second one over here, this is scale. Click on it. And I don't even need to put values in over here on the left. I can just come over here and grab and drag like I can any other picture. Again, you're going to see that it's going to throw it off from being in the center. If I go to the center of the picture and I left click, I can drag it back. And basically I'm just going to try and scale it here off the corner and move it around off the center till it is kind of proven to be the right size. I don't need to get it perfectly centered this way. I can center it back up using the centering tool over on the left, but I want to make sure that I got it scaled to fit and I got it kind of in the right spot. So it looks pretty good, scaled like it's going to fit. It'll fit in between the juice groove and everything real nice. So I can go ahead and close it. And I got my bitmap, my picture here. What I'm going to do is click on the Align tool over on the left. And with that Align tool pulled up, I'm going to see here that Align selected objects to the last item in the selection. So I'm going to pick the picture first because that's not what I want to move the lines to. I want to move the picture to be centered up on the lines. So I click the picture first, I hold Shift and click the lines next that I want to center it up on, and then I can come over here on the left to Align Center, and you'll see how the picture moved, not my juice groove line. And now I got it all nice and centered up on the cutting board. So it's a very simple, easy way to do it, to get your pictures on there. And then in the software, we're going to have to actually convert this into vectors. So I'm just going to click anywhere, left click anywhere to sort of deselect everything. And I'm going to come over here and there's an option called Trace Bitmap, which is going to take the bitmap or the picture and convert it into vectors or polylines so that we can program it. So I click on that, and I'm going to go click on my bitmap. So go over, left click on the picture, and it gives me a couple options. I can either trace it by color. This is what you'd have to do if you had a colored image, or I can trace it by black and white, which again, my recommendation, at least starting out, if you want to have success more easily, always try and find black and white pictures, easy, simple silhouettes, and trace them by black and white. When you trace them by color, you're going to have to do a whole bunch of adjustments over here on the left, picking the number of colors and the pixel filter and the fading and all this other stuff. You're going to have to go through a lot and probably a few tries before you get it to trace the bitmap correctly. Black and white is pretty foolproof and very easy. Again, if you ever have a problem, you can just hit Control Z and back up, if you need to redo anything. Before I actually hit, apply or close, I get the ability to preview. And what I can do is preview it as many times as I want, and it won't make the actual lines into vectors for me until I hit apply. So it can be nicer when you're in the color picture level. Preview it, see if it lines up, change some settings, preview it again, see if it got better or worse, change some settings, preview it, see if it got better or worse, and work your way until you're happy with where the lines are. So I'm going to click preview over here on the left, and I can tell if I scroll my mouse and I zoom in that it did a pretty darn good job of hugging the edges of that picture and giving me all the lines and everything that I wanted. Again, if it didn't, I could change some settings. I could hit preview again, let it update, and see if maybe it got a little closer for me. So with that in there and it looks good, I'm going to go ahead and I'm going to hit apply. That's going to save those lines for me, and then I can hit close. And now you can see how I kind of have the lines and I still have my picture there in the back. I don't really care about the picture at this point now because I've converted it into lines and I no longer need to see that picture in the background obstructing my view of the stuff I'm actually working with. So if I want to eliminate that bitmap picture, I can either come up here to layers and I can turn off the bitmap layer by clicking this little black circle, or I can come right over here and I can turn that bitmap on and off with that icon over there. So either method works, and again, it just gets it so all I'm looking at are the lines. I don't have that picture in the background obstructing my view at all. All right, with all that in there, I am ready to do my CAM, my programming. So over here is the design tab. What you do in the design tab is click up here in this switch to toolpaths command button. That's going to start opening up my menu over here. And then over here, I can start to select my different toolpaths based on the things I need to do and the tools I have loaded up. And select my tools and make a tool library and all this kind of good stuff. There's a lot that you can play around in over here. We're just going to be keeping it simple for right now. And so what we're going to do is we're going to start out by profiling our piece and using the 1/4 inch tool that we use for profiling for as much stuff as we possibly can. So in the profile, the top thing for all of our toolpaths are the starting height and the depth. So where do we want to start? We want to start at the top of the piece. How deep do we want to go? We probably want to go just slightly further than our workpiece. So if our workpiece is 1.375, if I go 1.395, I'll be able to cut just below the top of the work, or just below the bottom of the workpiece, and completely cut the sides free when we're all said and done. Then I can go down here and I can select my tool. All of these tools, all of these part numbers and everything are from a Mana tool. So we can go back and we can Google search Amana tool, and it'll take you to their website here where you can pretty much type in any of those tool numbers from the VCarve software and you'll find those tools on their website. So 46094, if I go to their website, 46094, I'll be able to find right there, that is what that tool is. It's a 3-fluted 1/4 inch tool, and the big part is the cutting height is 3/4 inch. So that particular tool won't work for us because we got to go 1 3/8. The only tool that's in the tool database that we can use that works for us is the one that's sort of already populated over here for me, but it's 51646. So if I go back, 51646, and if I get that tool pulled up, we'll see that it is a 1/4 inch diameter with a 2 1/4 inch length of cut. The tool we're going to actually use only has 1.5 inches length of cut or cut height, but that tool that we're using is not actually in the Amana database in VCarve at the current moment. It's a relatively new tool and it's not in there yet to be able to be selected. But if I look at the top of the Amana website, I'll see that this is a solid carbide CNC Spiral O single flute plastic cutting tool. So if I go into VCarve, I can go under Amana Toolmaster and I can go under plastic and 1/4 inch, and under plastic and 1/4 inch I should be able to find my 51646 tool that we have to use. All right. When you click on that tool, it gives you all of the cutting data, the step over, step down, all that different stuff. What we're going to do is we're going to adjust the step over to be 0.1. That'll come more in handy when we're doing our actually 0.188. That's going to come more in handy when we are milling out the pocket. The feed rate we're going to set is going to be 17. So we're going to drop it down a little bit because this is a pretty long tool. And down at the very bottom, you can set the tool number, whatever tool number you want. I think it's easier just to go tool 1, 2, and 3 and keep it really simple for yourself. If you're sharing the machine with a bunch of other people, you guys might want to talk about which tool you're doing for what in order to try and not overlap tools with each other. But for this, first tool going in the machine, tool 1, going to click apply, going to click select. That should pre-select my tool for me. I can go under here to edit passes, and under edit passes I can have free range to add as many passes as I want for the cutting and specify the depths for all of them. If I add a pass and I make it 7 passes, what it lets me do is go through and I can define each of the depths of the passes, and I can make sure that the first pass is relatively shallow in order to prevent a lot of splintering of the top of the wood. So if I go a 1/16, then the next one I can go 5/16. So I'm going to take a 1/4 inch cut each time. And with that 1/4 inch cut each time, I will be able to work my way down and keep that shallow first cut so I don't splinter the wood. And again, they'll show you the lines over here. So if you put a number in and this flies way out of the way, then you can kind of tell, like, oops, I must have done my math wrong in there somewhere, because this shouldn't be, you know, all these lines should be pretty evenly spaced. Like that one, did my math wrong. 788. Get them spaced out right. Go to the last one. 1.032. Go to the next one. 1.287. And we'll leave the last one at the depth that we wanted, and you'll see even if you click on it, it's all grayed out. That's the depth that we specified over on the right under cutting depth, and that one's going to be locked in no matter what. So with all those depths in, we'll hit OK. The next thing down, machine vectors. Pick and choose how you want to cut. You want to cut on the outside of the piece or the inside of the piece. I want to cut on the outside of the piece because we are going to be doing the profiling here. Do separate last passes, all that other stuff you can edit if you wanted to. If you want to do a separate last pass, basically what it's going to do is circle around the whole piece after it's finished cutting all of the wood away from it. That could be nice if you really need a nice outside finish. You can try and cut everything all at one shot to try and clean it up. With such a small tool and such a long flute length, we're going to not do that, because if we do that, we run the risk of breaking the tool off. What we're going to do is try and use our lead-ins and lead-outs to keep us from ending up with any bad surface finishes. So tabs also, if you wanted to keep the thing in place and cut it out from the outer shell later on, maybe you had like 10 pieces you were all trying to cut out of one board, tabs usually will be a nice thing for that. You can have all 10 of those pieces inside of your workpiece and then go through later with like a skill saw or even a hacksaw, and you can cut those pieces out from the board and just sand the tabs off. But that way they're not breaking free and popping loose on you as you're going through and doing all of your work. We come down here, we'll go to leads. Leads is where we're going to add lead-ins and lead-outs onto this profile to try and keep from like leading in and out right on the side. If we lead in and out on a corner, if we have anything dig in or come out funny, we should be able to sand those down nicely and hide that blemish pretty well. So I'm going to add leads. Straight line leads, and depending on where I want to lead in and lead out, will change the angle and everything that I put. So if I put 0 and I make the length like 1 inch or so, and I lead out, I should get the same 0 on the lead out as the lead in. And what I'm going to do is try and put that lead in or lead out right on the corner if I can. So I'm going to go over to the start at, and with the start at, I can try and pick the corner of where I want it to start in order to avoid my lead in and lead out ending up like, again, right in the middle of the piece. Leads, let's make that actually 45-degree angle. Let's see what happens. Alright, and we're going to name this profile down at the bottom under name so that we know what that toolpath is when we go to look at it in our tree. Click calculate, come up here and just answer yes. It's just saying you're going to cut through your piece and into your sacrificial board, which for us, that's fine. We don't really care. All right, and there is our tool path, and you can see how that kind of leads in and leads out on the corner. If you want to be able to scroll this around and look at it, you're going to hold down on your right mouse button, and holding down on the right mouse button is going to let me scroll it around, take a look at everything, make sure that my lead-ins and lead-outs start outside of the piece, which is what we want. And I think that looks pretty good. So we're going to roll with it. Hit close over here on the right, get your image to pop back up, and now we can get back into doing our next toolpath. I'm going to go over here to Pocket Toolpath, and Pocket Toolpath is going to allow me to pocket out this piece with 1, 2, or 3 different tools depending on how many I need, and try and get this logo ripped out here and then the final and last tool we'll put in a 1/2 inch ball end mill and we will do the juice groove. I'm going to rough this pocket with the same 1/4 inch tool that I cut the outside with. So because I'm doing that, I want to try and put those two operations one right after the other one. So I'm going to go over on the right to pocket toolpath. I've got a 1/4 inch end mill to start with, a 1/16 inch end mill next. Again, you can go under select and you can pick those tools. You can edit those tools as much as you need. You keep adding tools in here for however many tools you want to add in to cut the pocket. So if you put in a 1/4, an 1/8, and a 1/16, the VCarve software will automatically cut as much as it can with the 1/4, cut as much as it can with the 1/8, and cut as much as it can with the 1/16 to finish out your pocket and get it to look how you want. We're just going to go 1/4 to 1/16, keep the tool changes down. It might take a little bit longer to mill the pocket. Again, depending on the shape of your pocket, will kind of determine how the program's going to go. Otherwise, same thing, cut depth, how deep do you want the pocket? We don't need the pocket to be overly deep, so we're going to go 1/8, 0.125, and we're starting at 0. So we're starting at the top of the piece, and we're cutting down 1/8 of an inch from there. 1/4 and 1/16 inch tool, that's exactly what we want. Edit passes, what I'm going to do is I'm going to go to 2 passes, and I'm going to have the first pass be a 1/16 or a 32nd, something like that, to keep from breaking into the material too much and again causing it to chip out, and then let the final pass go all the way as deep as we need. If you just go the full 1/8 inch, you run the chance of really splintering at the top of the pocket, and it's going to be really hard for you to clean it up by, you won't just be able to run some sandpaper over the top. The last thing under there is how to mill the pocket, offset, raster, climb, conventional. I just go with offset and climb. Again, if you ran into problems with that, you could change those up. Climb and conventional just changes how the tool moves in relation to the direction that it's spinning. Usually climb milling is the best, but not always. Again, at the bottom under name, we're going to rename that. We're going to call it logo pocket. And we're going to go through and hit calculate. That should calculate us a toolpath. Oh, screwed up there because I did not pick my pocket yet. So if you make a mistake like that, go back over to the right, go over to where it says logo pocket, right click on it, hit edit, and then right above where we named it, there's the vector selection. We need to select our vectors. We got to be able to pick our image here. There we go. It's kind of hard to see underneath of the toolpath. If it's hard to see underneath your toolpath what you're clicking at, same thing up here in the left. You can go up and you can turn off those different layers, the toolpath layers here with these squiggly lines, and I can make sure that I'm definitely clicking my Buffalo Bills logo and then calculate, and there we go. Now I got the toolpath looking like I want, where it's just concentrated in the logo. If I want to be able to check and see what the toolpaths are looking like, I can uncheck mark over here and it will blank them out. So like if I don't want to see the profile anymore, I can uncheck it. But the main one is I want to see how much is the 1/4 inch tool cutting versus how much is the 1/16 inch tool cutting. So if I blank out the logo pocket, the lower one, that's going to blank out everything that the 1/16 inch tool would cut. So I can see that the 1/4 inch tool is doing a pretty decent amount of work here. It's really cutting a lot out. And then if I flip those and I blank out the 1/4 and I turn on the 1/16th, I'll see that the 1/16 inch tool is coming in and it's milling the final shape, and it's coming in especially on the hooves and the little chin beard there and everything, and it's cleaning up those corners where the 1/4 inch tool would never be able to get in that far. Now if I want to be able to simulate and check this whole thing out and see what it's going to look like when it's done, I can use this menu over here on the right hand side, and I can say reset preview, and then I can say preview all toolpaths. And when I do that, it will take and make a little tool, virtual, run around the piece and mill all this material out, and I'll be able to see what this logo is going to look like when it's completely done. So with that done, I can come in here on the corners and rotate, and I can see if I have enough definition in the corners to give me what I want. And I can make sure we milled everything out like we wanted to. If you only do this with a 1/4 inch tool, you won't get these nice sharp corners. And again, you're going to save a lot of time. If you don't need the really sharp corners, if the logo looks good or whatever you're trying to do looks good without the sharp corners, you can save yourself the risk of breaking a small tool off by just milling it all with a 1/4. You could try a 3/16 or an 1/8 and see if those give you enough definition before having to go all the way down to a 1/16 or a 32nd and getting a really, really small tool to get a really, really fine corner. So with those in there, the pocket looks good, the profile looks like it's good, everything looks pretty good. The last thing we're going to do is throw in the 1/2 inch ball nose tool and come in and mill the juice groove in. Again, relatively easy, and we'll simulate the whole thing all said and done and make sure everything looks like it should. So I'm going to go over on the right, hit close. That's going to pull me back up my vectors, my lines there for me to be able to select. And what we're going to do the juice groove is we're going to use the profile toolpath, but we're going to put the tool on the center of the line we click instead of inward or outward like we did when we did the actual profile. So for our cut depth, we don't want the juice groove to go all the way down through the thing. We just want it to go down a little bit. So I'm going to pick like 0.2, 0.188. If you go 0.25, you'll have cut exactly half of the end mill's diameter, and you will have the sharp edges at the top of the juice groove. I don't really like how that looks, so we're going to stop just shy of halfway up the tool so we don't have a fully sharp edge on the side of the juice groove. Under the tool, we'll go to selection. Again, you can go on Amana's website, find all the different end mills and stuff if you need, but I know that we need a ball nose end mill with a 1/2 inch shank, and they're going to be relatively simple to pick one because they're all going to be able to cut deep enough. The only problem with some tools that you need to find a specific one is to have enough cut height that you can actually reach the bottom of the geometry that you're trying to cut. 46-380 spiral cut, spiral nose, ball nose, up cut, 1/2 inch end mill should be perfect. It should get me everything that I need in order to make this cut. If you get a tool where it says that you don't have any settings in there, you can hit the copy, and that will give you all the settings that you're supposed to have. 260 inches a minute for a feed rate seems a little high. We're going to step that down, let's say 100, and let's step the plunge down to like 10. And let's change the tool number to tool 3 because this is going to be the last tool we're going to load in the machine. We're going to hit apply, and we're going to hit select, and then that will now be the tool up there on the right that we're going to use. Edit passes, I'm still going to go 2 passes, and I'm going to make sure that the first pass is very shallow. And again, that shallow first pass is going to help the wood from splintering. Under machine vectors, this is where we're going to put it on center. So by clicking on, you can see the little picture changes and the tool goes down the center of the vector. That's exactly what we want because we want that juice groove to follow right down centered up on where that line is. No need for lead ins or lead outs on the juice groove. It's a very simple operation. Click the vector that I want it to be on, and go down and name it Juice Groove and hit calculate. And now if I rotate again, click the right mouse and hold it down, I can see that I got 2 lines there for the juice groove. And if I simulate those toolpaths, if I do reset preview, check all those toolpaths down there at the bottom and hit preview all toolpaths, I'll get the whole cutting board all done. I can see the profile looks good, the juice groove looks good, the pocket looks good, everything looks good, and just the way I want it. Oh, center it up there. Alright, now if everything looks good and it looks the way you want, you can go ahead and post the code. Posting the code is going to be done by closing out of this preview window and going to let me find the one right here, Save Toolpath. Click Save Toolpath. Now, when you click to save the toolpath, you've got some options here in the top. Visible toolpaths to multiple files, because on the mill we're using, you don't have the ability to have an automatic tool changer. So you need to sort the files so that each toolpath has a separate file, so that the machine will stop, so that you can load the next tool, so that you can run it again. By checking group where possible, instead of getting 4 programs, right? 4 programs would be 1 for profile, 1 for pocket clear, 1 for pocket, and 1 for juice groove. Group where possible will group together profile and logo pocket because they both use the exact same tool in those operations. So because they use the exact same tool, we can have it make our program for us with both of those saved together, and it'll just shorten the amount of times we got to load programs and run the machine and everything like that. Again, if you did the whole thing with a 1/4-inch end mill, visible toolpaths to multiple files, group where possible, and you would end up with just 1 file because you're always using just the same tool. Click our post processor at the bottom, click our type of program out of the bottom, and then check all the toolpaths that you would like to export. In this case, I want to export all of them. And once that's done, you get Save Toolpaths, and you'll get a thing that'll come up for you on where to save it. I just have a separate thing on my computer where I save all my programs, and I put them right in to that folder, saved. All right, and the very last thing that you need to do is actually to go to those programs. Open file location, and at the end of those programs, you're going to right click on those programs and hit rename, and instead of it saying .g code, we're going to erase the .g code and we're going to have it say .nc. And you would have to do that to every single one of those codes because the machine only recognizes the .nc. It does not recognize .g code files. So with that, once those are all done, drop them onto a USB drive and put them in onto your CNC, and you'll be all set and ready to go to run off your cutting board. All right, hope this video was helpful to you guys. Again, you can go back, look at it anytime, and keep an eye out from ICD for some VCarve Vetric programming and CAD class in the future. All right, good luck.